Welcome to the third in a series of NTPEP webinars that are aimed at introducing some of the newer evaluation programs. To date, we have had webinars on spray-applied pipeliners and concrete coatings and sealers. The webinar on epoxy and resin adhesive bonding systems will be next week on August 29th at 1 p.m. I'm Bill Reel with NTPEP. For those of you who may not be familiar with it, NTPEP is the National Transportation Product Evaluation Program. NTPEP is an AASHTO technical service program that can provide savings to the states in the form of reduced manpower and other resources needed for in-house evaluations. NTPEP can also provide more complete evaluations in cases where states do not have a robust evaluation protocol in place. The way this works is manufacturers submit their products to NTPEP. The products are evaluated following an evaluation protocol that is designed by the appropriate NTPEP technical committee and then balloted to the member states. Manufacturer pays the testing fees to NTPEP, and the testing lab works for NTPEP, assuring independent and unbiased evaluations. Results are made available to the member states online through the NTPEP data mine. States can then compare the NTPEP results with their own spec to determine acceptance. Today's presentation will describe the NTPEP evaluations of detectable warning systems. This presentation is being recorded for future use and will be available online at the NTPEP website. Questions can be submitted by typing them in the comments and questions box on your screen. One of the hurdles of starting an evaluation program such as this is that manufacturers are reluctant to submit their products and pay the testing fees until they see the states require them to do so. At the same time, states may be reluctant to require NTPEP testing until they see that a number of manufacturers have had their products evaluated by NTPEP. Given the potential benefit to states, it is important that states take the first step to get things started. I would like to encourage you all to watch this webinar, review the work plan which describes this evaluation, ask questions, and consider how this program can help you. Assuming that you see benefits here, then it would be helpful to notify manufacturers of the detectable warning systems of your intent to require NTPEP evaluations of their products. Notifying them of your intent to use this evaluation will encourage manufacturer participation and provide the states with a robust, independent evaluation to base their detectable warning product acceptance on. So having said that, I'd like to introduce Karen Byram from the Florida DOT. Karen is the chair of the Detectable Warning Systems Technical Committee. Karen?
Hello, everyone. Welcome. Thank you for attending. We're going to talk about the Detectable Warning Systems Committee. As you can see from the photograph on the screen, what we're talking about are these warning mats that are placed on the edge of the roadway for visually impaired people. According to the United States Access Board, detectable warnings are this distinctive surface pattern of domes that visually impaired people can identify either through the color difference or by the tactical feeling from their feet as they approach a street crossing or hazardous drop-off. These are required to be used, and they are used in all 50 states, not just by the state, but by local agencies and private companies and facilities as well. Here is a photograph of a detectable warning system in a parking lot area. The detectable warning system is the yellowish orange color that you see in the screen. The concrete and the asphalt is considered substrate, and these products are normally installed in a concrete surface, though they can be installed in asphalt, though that's not the normal practice. Other names that you might call these detectable warnings in your state would be truncated domes, tactile ground surface indicators, tactile pavers, blisters. There's numerous other names for these, but they all mean the same thing. In this presentation, I'm going to cover the development, how we came about this work plan for the detectable warning systems. Bill will talk a little bit about the state survey that he's been conducting for the use of this work plan. Then I will go through the details of the work plan and Jonathan will wrap it up with the e-application submission process for manufacturers who want to submit their products for testing. So jumping in, let's talk about the work plan development portion. There's a definite need for the work plan. The majority of states will test the geometric requirements, but there's so much more involved with these products as demonstrated by these photos. In the upper left-hand corner, you can see there's actual material missing. In the upper right-hand corner, the pavers that have been used, their surface is wearing away, and there's a color change that can affect a visually impaired person. In the bottom left-hand corner, it's even worse in slide number 3, where the material is almost completely gone. And in number 4, if you look in the lower right-hand corner, you can see the tile actually lifting away from the substrate. This causes a trip fall hazard for both visually impaired and non-visually impaired individuals. These deterioration impact the users because they lose detection capability for the sight impaired, creates trip fall hazards. But for the facility owner, that trip fall hazard creates a liability. And because of that, you have your increased maintenance costs for repair, replacement, and inspection. So a facility owner would be very interested in trying to get products that once they're installed will stay installed without trip fall hazards or without degradation. And that's why we were looking at this program and at these products specifically. So back in the early 2000s, the states voted to have the National Cooperative Highway Research Program actually spend some money and do some testing and identify recommended procedures for testing and evaluating these warning systems. The report came out in 2010, and it is called the Recommended Procedures for Testing and Evaluating Detectable Warning Systems. That report went through to identify exposure regimens, test procedures, and evaluation criteria that would provide long-term performance and durability for products to ensure that they meet the Americans with Disabilities Act accessibility guidelines. And what they identified in that report were a number of deterioration mechanisms, from freeze-thaw and ultraviolet damage to snow removal, thermal cycling, impact, corrosion, salt scaling, and settling of pavers, just to name a few. Taking that into account, I started to identify test methods to simulate those conditions and to identify products that could pass or fail or resist significant deterioration. So when that report came out in 2010, the NTPEP states got together and they requested a committee to start based on that 670 report. The committee was created and a work plan was identified based on the 670 report, which the report didn't necessarily take into account cost of that testing. It just identified testing with cost not being an object. And so the original work plan that was developed was later identified to be way too costly. Getting state buy-in was very difficult. Manufacturers significantly refused to participate because it was a very exorbitant cost, and the committee was subsequently disbanded. But in 2016, the NTPEP has an implementation task force committee that looks at new opportunities for expanding the NTPEP program. And once again, this committee was asked to look at detectable warning systems. So the committee conducted a survey of states, and they were able to identify a significant number of states that would be interested in a work plan. The committee then looked at the mistakes of the past and with an idea of improving that process. So what they did was they conducted another survey of the states, but they also wanted to know exactly what specifications and test methods the different states were using. And so a tabulation of all the different states looking for a commonality in the different test methods was created. The committee went back and looked at the NCHRP 670 report to glean what they could from it. And AASHTO TP 103 had been created, TP standing for a technical provision, and to take into account a lot of the testing that was in the NCHRP 670 report. AASHTO also has a standard method, M333, that talks about the specifications for detectable warning systems. So for those of you who aren't familiar, the AASHTO TP 103 is part of the technical subcommittee D4 for safety devices. And its primary objective is to provide that repeatable set of tests to evaluate the durability. And it involves actually attaching specimens to concrete slabs to provide the testing for the warning sidewalk systems, rather than just testing them individually. They're actually, and I'll talk about this more in depth, they're actually put onto a concrete slab for the product testing. AASHTO M333 is also part of that same subcommittee, and its purpose is only to establish geometry of the detectable warning surface. And the geometry that it uses comes directly from the United States Access Board. We also looked at individual states that would have modified methods. Here's an example of some of Florida's test methods, where they took some of the NCHRP tests and some of the AASHTO ASTM tests and AASHTO tests and modified them for specific use on detectable warning surfaces. So now I'll turn it over to Bill. That's how we ended up with the current plan. I'll talk about that in depth in a little bit, but I'll now turn it over to Bill to talk about the state survey of use for detectable warning systems.
Okay, so you can move to the next slide, Karen. Great. So I've been contacting states to learn how they are currently specifying and evaluating detectable warning systems. I've also used this opportunity to describe the NTPEP evaluation and discuss it and find out if there's interest with that state in using the NTPEP evaluations of detectable warning systems. To date, I've had responses and had conversations with 38 states. I'm hoping to get some more here before I'm through. Of those 38 states, 15 of those states have expressed interest in using the DWS evaluations that NTPEP is doing. Of those 15 states expressing interest, 4 would want to see a winter maintenance exposure field trial of some sort. 15 states have not yet considered it, so that was an opportunity for me to inform them about the program and see if some interest couldn't be generated there. Of the states contacted, 8 states have specifically said that they are not expecting to use the DWS evaluations. So in the course of my discussions, I was trying to find out how they're currently specifying an evaluation. Karen, if you can move to the next slide, please. So some general findings. Many of the states out there now are basically evaluating dimensional and color characteristics to make sure they're meeting the ADA requirements and aren't necessarily doing any durability testing or that type of thing. I did encounter a couple states that had warranties that would require a replacement within a certain period of time if there was a certain level of degradation of the panel. I found a lot of states who accept detectable warnings simply based on certification by the manufacturer that the product meets the specification, which always includes the ADA requirements for dimensions and color contrast and that type of thing, and may include some material properties. And then I found 6 states of the responding states that specifically require cast iron panels. As I said, I'm going to work on this some more and see if I can't get some more responses and additional information. And this will when the survey is completed, it'll be reported on the netpep.org website. And that's it, Karen.
Okay, thank you, Bill. Now let me talk about the actual work plan protocol and go a little bit more in depth into the test methods so that you can understand why we selected the tests that we did and how those tests are going to be performed. From the collected data that the committee gathered, the important deterioration mechanisms were identified. We identified that for functional performance, it was color contrast, slip resistance, mechanical integrity, dimensional stability, and adhesion bond stability for the product. And the most significant degradation mechanisms affecting performance were freeze-thaw, abrasion, ultraviolet radiation, moisture causing changes to the product, as well as damage, extreme temperatures, and actual physical stresses caused by the impact of snow removal devices and by traffic. So from that, the committee created the work plan, and the committee used as the foundation of the work plan the AASHTO TP103 2015 version. So you'll see a lot of references to changes that are different in the work plan. The 2019 version of TP103, the committee worked with the AASHTO subcommittee of materials and actually updated that TP103 to incorporate the changes in the work plan. That was so we have been working on this work plan under the oversight of that AASHTO committee so that the two methods will match. For terminology throughout the work plan, we talk about the different kinds of products, but we also talk about the different way that those products are installed. So you have cast in place, which is cast into the wet or plastic concrete for adhesion. You have a surface applied warning, and that is a system that is applied to the surface of cured concrete. That can be adhesive mounted, anchor mounted, or both. The field in this case is integral with the domes. The surface applied single dome or array is a little bit different. It involves single truncated domes that are adhered to the substrate as part of an array of separately applied domes or domes that are created at the time of installation. The field in these cases, all these cases, is created separately from the domes. And there's also brick or pavers, which are exactly what they sound like. They're brick shapes, pavers, that are typically rectangular blocks that have the detectable warning blisters on them. So here's an example of surface applied products. An adhesive goes down and a single panel or multiple panels are then mounted into that area where the adhesive is onto the complete cured surface. Anchor mounted is there are holes that are drilled within the device. You can see here these are also a mixture of anchor mounted and adhesive mounted because you can see the holes here where they are then later going to put in these anchor bolts for more complete application, a more durable application of this product. Cast in place, the devices, the systems are three-dimensional. The bottom that is showing here has features that when they're put into the wet concrete installation, the concrete will flow into and will create, when cured, a very strong bond to hold that product in place. Here they are installing them. Typically, these go in, they can go in either where the entire sidewalk area is still plastic, or in this case, they cut out a specific area for post-installation where they then fill this in with the wet plastic concrete for the installation. Cast iron works the same way. Cast irons are typically wet installation. They have structures on the bottom of the panel, and they are placed into the wet concrete. Bricks or pavers are done the same way, though they usually don't go into concrete. They are usually grouted into place or sit on a sand bed. But you can see the individual bricks or pavers here creating the dome array of the finished product. Surface applied or formed in place, as I said, are single dome installations. And you can see these individual domes have been installed onto the concrete surface here. These are not very common, but they do exist. And the other is formed in place. This white portion here is a mat, a form, where the liquid epoxy, in this case, is being squeegeed into the form. The field has already been created separately, and now they're creating the domes. And when they lift this mat off, it will leave behind a domed shape of the material. And it leaves a complete array. They typically do not form these as single domes, though they can, but it's usually as a touch-up or maintenance kind of application when they do that. So now that you understand the kind of products that we'll be testing and how they're installed, the work plan itself consists of fabricating the test specimens. Then it exposed those test specimens to a series of non-destructive testing, destructive testing methods. The sample then goes through an accelerated weathering exposure, and the non-destructive and destructive tests are reconducted to see what kind of degradation methods have occurred to the product after it has gone through the accelerated weathering. So the first part is to prepare the samples. There's very specific instructions in the test methods how to do that. Photographs are required so that you can see throughout this process, so you can see before and after, and also to identify the actual product itself for future reference. The products are installed in accordance with the AASHTO method, but also within the manufacturer's or supplier's instructions, so that these will be installed for the testing the same way that they would be installed in the field. They are literally making concrete slabs, whether it's a cured concrete slab for a surface applied or installing the product in the concrete slab when it's still plastic for the other types of installations. All that is done according to the manufacturer's instructions. The non-destructive tests are a series of visual and microscopic evaluations, dome shape and geometry, slip resistance, and color measurement. The visual and microscopic evaluation is looking for defects before and after the accelerated weathering. We're looking for degradation that occurs at a microscopic level that could lead to longer problems down the road. Some of the products are not the defects are not microscopic, as you'll see in some photos. The domes and spacing dimensional testing is also tested before and after accelerated weathering. This is to see if it changes that dimension over time. So here's an example of visual and microscopic evaluation. You can see there's degradation here along the side of the product, and around the domes themselves that may lend itself to problems in the field later with early failures. The dome shape and geometry is taken straight from the Americans with Disability Act. We want to see, does it change? Is the product warping in the field? Are the domes changing their shape, moving, etc.? The spacing dimensions also, besides the domes, the spacings is also tested. Non-destructive testing is slip resistance. We're looking for both resistance on the domes and on the fields. There are different users with wheelchairs as there are from pedestrians, etc. And so the field slip resistance is as important as the dome. Color measurement testing is required because there are users of these products that are visually impaired but not blind, and so they're using the color contrast more than the tactile warning to identify where these are located. Here's an example of the slip resistance testing. The skid has the ability to make adjustments so that it can be tested both the field and then it can be shifted to be positioned on top of the domes exactly, and the surface of the domes can then be tested as well. A weight is used. These are some, and you can see the sample here is on the concrete slab itself. It's already been installed. Some testing that Florida did on these skid resistance testing, these are actual product values that we have, and between dry and wet, you can see the huge variation that we identified that can occur on these different products. And so these are recommended wet, dry values. These are some of the values that Florida is using. You don't have to use them, but we were identifying minimums for wet and minimums for dry coefficient. Here's color measurement testing. Because colors can change after ultraviolet exposure and heat exposure as well. When a product, something to note, when your product is available in multiple colors, for example, Florida allows yellow, red, and black to be used as colors, then the manufacturer can have the other colors tested as well for the color change without going through the entire series of tests for each individual color. So a manufacturer can submit one product to go through the entire series of tests, and then for a separate fee, they can submit each of the other colors just to go through the color testing. Here's an example of why color testing is necessary. We did a series of tests in Florida and Gainesville where we had the manufacturers come out, every manufacturer that we had, and install their red, yellow, and black product. And then we looked at what happened over time. CAP-Y is one of the things that's identified often for identifying color change, but we identified it really didn't help capture the difference in the colors. Depending on your screen, this may be more obvious, the color difference may be more obvious to you than not. On the left-hand side of the screen, the color is red, a red brick color. And on the right-hand side of the screen, after 6 months, the red has turned to more of a brown color. We identified that the Delta E was much better at identifying the color change fade than the Delta Y was. So here's examples after 1 year exposure. The yellow is very hard to read, I realize, but this is the change in black, red, and yellow that we identified after 1 year of testing for each product. Some of them had very little color change. The products remained very stable in their color. Others had very wide gaps of changes to their product. And they were more than obvious when you saw them a year later. This is the same information with the delta E. We're only showing here the delta E, which is the change. You can see the same product here as a delta E shows very little change, although the red is more significant here than on the previous slide. And here's the other test with the delta E, the significant change that was identified on that. Again, the black line is something Florida identified. A delta E of 3 is right about the limit of what we decided that the human eye can see very well. And so that's why the line is drawn at delta 3. After these tests are done on the unexposed sample, now some destructive testing is done on the products, again on the unexposed sample, and that is resistance to impact from falling tup, resistance to impact from a simulated snowplow blade, wear resistance, and adhesion bond strength. The falling tup is identified in the test method. Again, photographs are used, as are the wear resistance and the bond strength testing. Here is the example of the falling tup, where you're actually trying to break a dome. There are 2 weights that are used, each simulating a different kind of damage, a 20 foot-pound and a 40 foot-pound. Here's the apparatus in the testing facility with that same sample that's been installed on the concrete slab. Wear resistance, a test specimen on the concrete substrate has been cut out, and it's being tested here for surface wear resistance. The dome heights are measured, and it's the amount of material or weight lost that is being reported. Here is some of the same products that Florida tested, showing very significant differences in weight loss identified with these products. So you can see there's a huge variety of how these products respond depending on what materials they're made of and over time. Bond strength is an example of how well this product is adhered to the substrate, be it adhesives, the anchor assemblies, or actually pulled within the concrete material itself. So a core is drilled around the different domes, and a pin is adhered to it here, and then the pin is pulled to see where the record of the failure occurs. Here's the same series Florida conducted. The ideal failure mode is a matte adhesive concrete failure where it actually pulls up part of the concrete. And that tells you that the concrete is the weakest part of that system, and that is the best installation method you can have. One of the worst things that can happen is a mat or a dome failure, followed by the adhesive itself giving way and leaving the concrete unscathed, meaning that the mat was not very well adhered to the product. After you go through that series of testing, the product is then exposed to a high temperature cycling that involves high and low temperatures, periodic abrasion to the surface to simulate day-to-day wear. A freeze-thaw is part of the temperature cycling where you literally freeze the sample and let it thaw, and ultraviolet light exposure. Each of those is identified in the testing protocol and how it is conducted exactly and with exceptions in accordance with AASHTO TP 103. The systems go through 15 thermal cycles. During that time, they're subjected to 4 abrasion cycles and ultraviolet radiation. They repeat that series of exposures in the same order 3 additional times for a total of 4 cycles to provide 60 thermal cycles, 16 abrasion cycles, and 1,000 hours of ultraviolet radiation. There's a cold temperature exposure as well. And in that case, it goes through the freeze-thaw with the same series of 60 thermal cycles, 16 abrasion cycles, and 60 freeze-thaw cycles with 1,000 hours of ultraviolet radiation. So here's an example of the product in the concrete slab being subjected to these cycles with the ultraviolet radiation. Here's another view of the setup with that product in the concrete slab. The abrasion is not the same as the wear testing. It is just a lighter abrasion, but it's considered and conducted in 4 cycles to simulate exposure from walking surfaces and potentially occasional vehicles driving over it. The freeze-thaw test actually involves holding it in a frozen state for at least 30 minutes so that the product literally freezes and has to be thawed out as part of the cycle. Here's another view of the ultraviolet light exposure. So once the samples go through those 60 cycles of the high temperature exposure and freeze-thaw exposure, then all the microscopic evaluation, dome spacing, slip resistance, color measurement testing, falling top, wear resistance, and bond strength tests are reconducted. And the difference in those values are recorded. Now here's something interesting that happened to a sample. After a series of freeze-thaw cycles, you can literally see the jacking that occurs on the device as it's coming up out of the concrete substrate. And that's an example of a failure mechanism. You've got a trip hazard here where the design of the product is not conducive for an area that's going to have freeze-thaw. The resistance to the simulated snow blade, we are not conducting at this time in the work plan. We decided that we would table that for right now to get the test method out and up and running, but we will consider putting it into the work plan depending on the interest that is identified from the states. TP 103 does have this method, a method for simulated snowplow in the test method. So northern states that want this testing can reference this test in their specs. A reevaluation cycle is also not yet been determined. The committee will be looking at that this year as well and adding that into the work plan in the future. So that's how the testing proceeds. It is ready to go, and I turn it over to Jonathan now for the e-submittal submission process.
Yep. If you can go to the next slide, and then I'll start talking. Alrighty. So we are anticipating that we will accept products by September, probably towards the end of September. We just have a couple last housekeeping items before we can open a cycle. We're going to use what we call a rolling submission cycle, which will allow manufacturers to submit products any time of year. And as they come in, it'll be first come, first serve. We will accept the application, send the product along for testing at TRI Environmental. And we've identified it to take about 120 days to complete the entire gambit of testing that was identified in the work plan. Next slide. So I wanted to give you guys a little bit of a view of what data mine is going to look like. The first thing that you're going to run into, of course, especially the manufacturer, is having to submit a product on that module. So this is an example of what the application will look like. You'll see there that basic information that we're going to collect. Do you require a certified installer? So we know how the testing facility has to handle your product. The installation method, whether it's surface applied, anchor bonded, adhesive bonded, cast in place, brick paver, etc. Then there's some other items about the product itself, such as the type of material, how it covers integral or surface applied, and then other items such as the materials required for installation. One other thing to note is for this program, we are going to give the option to the manufacturer of the environmental conditions they wish for it to be tested under, whether that's hot weather, cold weather, or both. And then we will conduct the testing accordingly based on the requirements of the work plan. And as Karen mentioned earlier, we are going to allow multiple colors to be added. You have the base one color, of course, for one product, with the option to add additional colors as you see fit. Those additional colors will undergo a truncated testing regime. They don't have the full gambit of testing, as Karen's already pointed out. But anyway, the last section that you'll have to consider as you submit an application is the appropriate documents that will be needed as well. This includes an SDS, installation instructions, and dimensional characteristics, with some other optional literature that you can provide as well to help better understand your product and help the testing facility better understand what special needs your product may have. Next slide. This picture here is the landing page. If you were to click on the Detectable Warning Systems link on the DataMine website, depending on your permission level, whether you're a manufacturer, state, or other, the information you'll see here will be a little bit different. But you'll have a list of the products that have been tested, that are completed. On the left-hand side, you'll be able to use advanced filtering to narrow down the types of products that you're seeing. And as I pointed out on some of these, you'll be able to multi-select the type of installation we're talking about, whether it's surface applied or cast in place, the type of materials that it's made of, the year that we actually did the evaluation. And you can go through and set this up as you please, and then the products that will be listed there will meet those criteria. And then directly from this page, you'll actually be able to download the reports, or you can click in and view a more detailed description of individual products. If you go to the next page, Karen, next slide. This is just more of a close-up of that list that you would receive after you filtered. And as you can see here, you have the ability to download the EAP information that was provided by the manufacturer. You'll have the ability to download the actual test report or to download both. With this module, it's going to work a little bit differently than a lot of our other modules in that we're not going to be displaying data in tables directly on the website. Instead, there'll be PDF reports that the testing facility has put together and is uploaded, and that's what you'll be downloading from this page, just to give you a better idea. Next page is the Detectable Warning System timeline. All of our modules have something like this, but it's definitely worth noting. It allows you to track your product, where it's at, the specific dates that different activities have been conducted on that. So you'll see, the application gets submitted, it's noted there, and then it shows when the test data is released to the lead state, when it's assigned to the testing facility, when it's finally released to the public. So you'll be able to just track every step of the process along the way. And this is something that is available in several other modules, if not all the other modules currently. So definitely a nice tool to have when you're trying to figure out exactly what's going on with a particular product. The test data itself, if you clicked in on an individual NTPEP number for a particular product, this is the page that you would land on. You'll get some of that basic information that we collected during the EAP process, such as the installation method, the additional materials that are required. It'll tell you the type of testing that we conducted, whether that's hot, cold, or both. Show you the colors that were assigned, and then you'll have the ability to actually download the report right from that single page for that individual product. The nice thing is we can upload multiple reports, so if we have additional color testing, we can upload those as individual reports, or we can upload them as an entire report. It's really up to what we feel suits us best for the committee. It leaves us a lot of options, a little bit more open-ended, and allows us to make adjustments. If adjustments are made to the work plan, rather, it allows us to more rapidly implement those into the program. And then the next page, Karen, will show us the actual what a report would look like. So if you click on one of the reports, one of the nice parts of functionality with this module is that it's going to utilize basically a full suite of Adobe features right within the module itself. So you can open the report. It'll display in page with the option, of course, to download. It'll allow you to go to individual sections. We can actually format sections and have quick references along the side. You can show other attachments that were applied to that report. And of course, all the other things like quickly to the first page to the last page, search features, and anything you could do on Adobe, you'll be able to do right within the module. Next page.
Okay. Thank you, John. This just a summary of what we've covered so far. And that is the development of the work plan, the state survey, the protocol and test methods of the work plan itself, and the e-submission process. So now I'd like to just open it up for questions, and John, Bill, and I will be available to answer them as time permits. Thank you.
Excellent. So if you have a question, I think the best way to do this is to use the question feature that's within the webinar sidebar that you probably have open. If any come in here in the next minute or two, I'll read them off and then Karen can answer them. Just to start us off, just to reiterate, I did have a question come in earlier if the PowerPoint will be available. And I did indicate we are planning to make the presentation available on the netpep.org website, well, probably within the next few days. Just had some questions come in. We have, is there any indication from manufacturers as to how many will be participating in this initial submittal cycle?
Okay, talking to manufacturers, they are mostly interested in how many states are going to participate. So again, we're at the chicken or the egg stage, that the manufacturers don't want to spend their money if the states aren't going to use this. There are several manufacturers who have been working with us on this work plan, asking a lot of questions. They are interested in this program. They have good products and they want you to know it. So we encourage states to participate with this to help encourage the manufacturers to participate.
We had a similar question, though with a little bit of a difference to the question itself. Have manufacturers shown interest in the NetPEP testing?
Yeah, there's definitely interest in it. I have several different manufacturers on the committee with me, and as more find out about it, they want to know more about it. They want to be involved. So the industry is very interested in this. They would love to see a national standard, and they want to see the bar raised on these products because they do make good products, and they want the sales and these states to recognize that good performance of performing products are necessary.
Is there any indication from manufacturers as to how many will be, oh, sorry, that one was already read. I apologize. Is testing for tactile walking surface indicators using this method possible?
Oh yeah, the as I showed earlier in the slides, many of these methods are currently being used by states and by Florida in particular for these tests already. They are already most of these methods are already in Florida's specifications. I'm in the process of modifying it now to include the entire work program. But yeah, the southern states see a lot of this degradation because we don't have snowplows. And so all these different types of products are being installed by local agencies and private facilities. And the long-term durability of these products is critical. The ultraviolet degradation. I was just at the grocery store yesterday, and half of the mat was gone over by the grocery store. So it's a very critical issue for everyone. But even cast iron can have freeze thaw problems in the northern states.
I had a question that I'll kind of answer here. Someone asked if they could be on the committee. I know we have several manufacturers who may not currently sit on the committee as industry representatives. I urge you to reach out to me, Jonathan Sirianni with NTPEP, and we can talk about that offline. And then I have, is testing going to include the directional indicators which are found on USDOT/FHWA's accessible shared streets?
Directional indicators are something we will be looking at adding on the committee. Talking with manufacturers, the products are produced the same way. It's just a geometric difference to those products. For people who aren't familiar with them, directional indicators, instead of being blisters and domes on the surface, are longer bars that, instead of telling the visually impaired caution proceeding forward, actually redirect the visually impaired to move parallel to the bars. You see them a lot on subway platforms, leading them to a safe area to get onto the subway. Other common uses are moving them away from areas where a shared use path is splitting off to, say, bicycle only, pedestrian only, to steer them into the pedestrian only portion of the shared use path.
I have a couple more questions here. Will there be a pass-fail indication that the product meets ADA requirements, or will states be required to determine that based on the info in data mine? NTPEP does not pass or fail any product. We simply make the data available to the states, and then you can use your state specifications to determine if the data is suitable for your needs. And then how will cast iron panels be tested? The visual contrast of cast iron and its performance over time is of interest.
Cast iron panels will be tested the same way as the other products. You're looking at their performance with corrosion through the cycling process. You're looking for physical degradation of the product, cracking around the domes, around the edges, that sort of thing after it goes through the process of the cycling of the temperature, corrosion. That's why photographs will be taken. You'll be able to see corrosion damage or areas as how the products are performing. The only pull testing that will be done on the cast iron is if the cast iron has been coated with something to give it a different color. There are some cast iron products where they have an enamel coating or some other coating on the surface to make them yellow or red. And so you'll be testing the coating adhesion on the pull test for those products. But yeah, they are part of the program and are specifically addressed within the work plan.
Excellent. I think we have time for at least one more here that I have. Do we have an approximate cost on this testing yet? I can take the lead on that one as well. I was actually putting together the fee sheet just the other week, and I need to finalize a couple items before it's available to the public. But we do have approximate costs for hot exposure only. We're in the $12,000 to $13,000 range. For cold exposure, it gets a little bit more expensive with freeze-thaw testing. You talk about 16 to 17,000, and then for both, you're looking 25 to 26 per product, thousand that is. But the actual fee sheet will be available to you at least by the time of the submission cycle opening up and being available. And whenever I send an email out letting all the manufacturers know about that, I will include the fee sheet along with that.
Yeah, and we encourage the states as they're looking at this and adopting this to identify a protocol which they prefer, the high temperature cycling or the freeze-thaw cycling. The freeze-thaw cycling goes up to a fairly significant temperature, so it would constitute the testing equivalency for the majority of states. But for states that do have extremely high temperatures where they notice that is a major degradation method, the high temperature cycling is available as a separate testing protocol.
And then a kind of a follow-up to that is, what is the cost for a secondary color only? Unfortunately, I don't quite have that cost nailed down yet. I will have that within about the next couple of days. I do not have it right at this moment. It will be less than the $12,000 to $13,000 range that I told you about for the hot exposure, though. And that is it for questions that I have. So I think unless there's any other ones that come in the next 10 seconds or so, Karen, we can wrap up.
Okay. I thank everybody for attending. Again, we welcome more comments and questions. I'm available to answer questions about the work plan. Jonathan is available to answer anything about submissions and the NTPEP programs in general. But we both are welcome you to submit those questions, and we'd be more than happy to work with you and start getting this program used for the betterment throughout the country. Thank you.
Thank you, everyone.